Take out what you need on your properties of logs there. While you're finishing it up, key things for you to register with here. Product property. Product is the answer to a multiplication problem. Y'all know that. So you've got here m times n, multiplying, and then product goes with addition. Okay, so quotient is the answer to the division problem. So you've got here m divided by n. Division goes with subtraction. Okay, and that's the same on your exponent rules. Remember? When we multiply exponents, they get added. When we divide exponents, they get subtracted. So those are common things in common for you there. Power, if it was a power, this n was a power, it comes down front to be a coefficient. Okay? We'll practice them up, practice them up, practice them up. When we, still waiting on a couple people to finish up, when we did the exponential and log, when we wrote them back and forth, it was just different ways of writing stuff. That's a lot of what this is. It's just going to be rewriting stuff in a different way, just changing things around. I got it? Everybody still need a second? Okay, no problem, no problem. No. Okay, let me go put it on my desk. Get my collection rocking. Sit there by your buddy Garrett's. They can hang out together. Alright. Let's see here if I can switch it over there for you. So, I'm going to start us off here with some ugly looking log functions. So this first one will be pretty, not too ugly. It just says, as soon as my marker wakes up, it says log base 3. You're in your notes. Great job. Log base 3 of 4x. So there's nothing to solve there because we don't know what x is. So you could say, well, let's rewrite it in exponential form. And you could, but you wouldn't be able to do anything more with it. Our directions for this now say to expand. So main two words that you're going to hear me use today are expand or condense. Expand means make bigger. Condense means make smaller. So pretty simple stuff on that. So if we're expanding, right now we have log written one time. If we're expanding it, we want to drag it out using those properties and write it with the word log as many times as we can. So what we're looking for after that log is any of those operations that we had in the properties we wrote down. Do we have a product happening, a quotient happening, or a power happening? And we only got one now. So with 4x, which of those three properties could I use? Product, because 4x means 4 times x. Very good. So I can break this down and make this longer, make it bigger, expand it using the product property. So what you would write, it's log base 3, so it's going to stay log base 3 of your first thing, which is just a 4, and then we said product goes with addition, so now I'm going to add that to log base 3 again of the second one, x, and that's it. You expanded it.
Oh, so we just simplify it out.
It's just another way of writing it, yes. Okay? So, what if I gave you log of 10x to the 5th. Okay, this one's got two of the properties being used. You can name one of them. It's got a power, so power property, good. There's another one. And the product, because 10x means 10 times x. Okay, so we're going to use the product first. So we're going to say this is the same as log of 10. Product goes with addition, so plus log of x to the 5th. Okay, just like we did on the previous problem. But now we can go a step farther, because on the right side over here, I can now do the power property. On the power property, the last one you wrote down, it says if you have an exponent, you bring it down to be a coefficient. So now we're going to write log of 10 plus 5, I bring that exponent down, 5 log x. And that would be your final answer. So you're not doing any real math, you just have to be able to follow those properties that you copied down and rewrite stuff. The reasoning here all goes back to calculator stuff. Before you could do all this in the calculator, you had to be able to break stuff down, and so it's still tested because of that, but it's not completely, it's not a big deal anymore. We just need to rewrite it. So we haven't done a quotient one yet. Let me find a good quotient one. I got what we need on that page. Alright, this one says the natural log ln of x over 3y. Okay, natural log, the ln, that works the same as the log. So our directions here say to expand it, because we only have one log up there. We want to write it with as many as we can. This one's got two properties happening. Can anybody find a property? Okay, quotient, and I hinted to you that. I said we need to do a quotient. We haven't done one yet. There's your division sign. So we've got a quotient. What else do we have? Product. Good, CJ, right here I got 3 times y. So I've got a product happening down there on bottom. Okay, so I'm going to start off. Let's just do the quotient first, since that's what y'all saw first, and that's what happens first. Quotient's friends with subtraction. So we'll say the natural log of x, and then we're dividing, so minus the natural log of 3y. Now, some of y'all won't have to pause like I did then. You can go ahead, some of y'all, and split this up. But I'm doing it in baby steps since it's our first day. But now I see that product like CJ was talking about, so I need to spread this out. So I'm going to bring down my natural log of x minus, now we'll talk about why I put that parentheses in just a second, my natural log of 3 plus this product, right, my natural log of y. Alright, so questions, and why did I put that parentheses? Okay, this quotient, right, quotient's friends with subtraction, says I'm supposed to divide by that whole thing. So if I didn't put that parentheses, it would look like I'm just dividing by the first one, right? But now I got that whole thing because I was dividing by the whole thing. So I kept that all together in parentheses, which is what Laney Joe was kind of talking about. Okay? Fabulous something? Alright, so we've expanded them on all those. I started you with one log and we made them longer. Let's work backwards now. Let me start you with a bunch of logs and see if we can squish it down and condense it. Let's say I've got, start off with a simple one, log base 4 of 7 minus log base 4 of 10. So our directions this time say to condense the logarithmic expression. So we've got more than one log. We want to be able to condense it down to just one log. Okay, so first thing you go to is you find what's happening, and you've got a subtraction sign. Subtraction is friends with which property? Quotient. So we're going to take this log base 4 and write those numbers as a quotient. So you just say log base 4. Attaboy, 7 over 10. That's it.
So these are the ones where you make these smaller?
Yeah, it's really easy. Yes, condense, we're making it smaller. Squishing it down.
Wait, and we knew it was a quotient because of
There's always a
Yes,
quotient.
ma'am. No, this isn't really much to it. Say it again. Oh, you know what you said.
Can I have two?
Uh-huh. Okay, let's say I've got 6 natural logs of x plus 4 natural logs of y. Alright,
There's two.
okay, there are 2 properties happening here, but there are actually 3 things you're going to do. Okay, Grant, talk to me about one of the properties you saw.
I see product.
Okay, got an addition sign, so that means we're going to take the product of something.
Power.
And then we got powers because we got numbers out in front. Very good. So both of these numbers out in front, the 6 is going to be a power on the x, and this 4 is going to be a power on the y. And then you're just going to take the product of that. Okay, so good job, y'all figuring that out pretty quick. I'm going to have an x to the 6th there. I'm going to have a y to the 4th there. And then the addition goes with product. So x to the 6th times y to the 4th. That's it. Squish that thing down to one little natural log.
That was
Power property was used and product. Oh, no, look, I wrote drawed up. P-R-O. What's a drawed up property? I don't know. New thing we can make up.
Nope.
We could finally make it big in a math book. Is that not your dream?
no.
That just crushed my soul.
She said no.
I mean, it wasn't even
Never.
No.
No.
It's okay, Casey. We'll get in the math book one day. Keep that drawed
Have
up
fun with
property
that.
in mind.
Die.
We'll create some funky formula to go with it. Everyone will be complaining about it.
Yep, especially Riley.
I will.
Product.
Name it after me.
Product Riley.
Complaining.
Property.
But it'll be the same as doing another property, but just a longer version. Kind of like an operation.
Alright, one more of those. And I'm giving you the biggest one in the book because CJ says I'm holding out. Log base 3 of 4 plus
Thanks, CJ.
2
The next one.
log base 3 of a half. This is just going to have them all. Well, it doesn't have a quotient, never mind. Plus 3 log base 3 of x.
Just add quotient.
Okay, so I mean, this looks like the scariest one we've seen so far. What do you see happening? Okay, I got 2 powers to happen here. I need to put that 2 onto the 1/2, and I need to put that 3 onto the x. So that, let me write over here, that's power property. What else do you see?
Product.
Very good. We're going to multiply and multiply, right? Alright, so this will be, now notice, and this has to work, if they're not all the same bases, then these properties are, you don't do anything. You would just say it can't be simplified. But we do have all the same bases, so we are going to bring that over, log base 3 of 4, right here, right? 4 times 1/2 squared times x cubed. That's funny, I put my squared outside and I put my cubed inside. I need to be more consistent. But there's some simplifying I need to do now. Okay, 1/2 squared right here is the same as 1/4, isn't it? Because when you square a fraction, you square the top and bottom. So this is log base 3 of 4 times 1/4 times x cubed. And now you can simplify one more thing. There's an easy schmeezy fraction up there for you. Okay, everybody see that Laney Joe's talking about? What do you get when you multiply that? 1. Log base, or 4 times 1/4 is 1. So I end up with log base 3. Do I need to write the 1?
No.
I can, but I don't want to waste my smartboard ink, because 1 times x cubed is just x cubed. So that whole big thing up there on the top is the same as log base 3 of x cubed. Good stuff. You did pretty good on that.
Wow, it's creeping over.
I know. Okay, just got one more thing to show you, still pretty easy. I would, I don't know if this thing will let me be as fancy as I want to be. I would go back to where you wrote this, if I can drag that, and I would add change of base. This isn't a property, but this is just another good thing, and I'll see if it'll let me scroll it in just a second. If I had we'll just do A and C. Log base C of A is equal to the common log of A divided by the common log of C. Now, I bet you if I scroll that up, it's going to, who knows what's going to happen. Let's just give it a whirl and see.
Is that A and X going?
No. Log base C of A.
Oh,
So, I mean, it didn't let me scroll it up for you. I'll write it over here. I'll write it over here. Now, I told y'all this the day we learned about where the log base button was on your calculator. This was around before calculators could change the base. So anytime you had a base other than 10, you could rewrite it in base 10s by doing the log. Did I write it the same? Yeah, by doing the log of the natural, that's common log of the big one divided by common log of the base. And so
Sounds like a lot more work.
it's a couple more button pushes, so it is faster doing it using the log base, but just want to show you, where's my mouse up there? Just want to show you the similarities on it. We're about there. So if we had, let's go over here to change the base. If we had log base 2 of 9, let's go through this the different ways. First off, let's do it using that change of base formula. Using the change of base formula, this would be the common log of 9 divided by the common log of 2. Okay? Which would mean, grab your calculator, the common log button's over on the far left by the 7. So I'm going to get log 9. I got about 0.95. I'm going to keep that on my calculator. I'm just getting abouts. Divided by common log of 2. I got about 0.30. So now I'm going to go up here and pick that 0.95, enter, divided by my last answer, enter, and so I got about 3.17.
How long is about?
Okay? So that's how they used to have to do that in the olden days. But now we can hit math, go find A, and fill in those boxes. Let's see if we get the same thing. Math, log base 2 of 9, enter. I got about 3.17, so same thing. So which way is better? Whichever way you do and get it right.
You don't just log down divide by log 3.
Yes, you could, yes. You could go back to what CJ's talking about here. Instead of me writing down the log of 9, I could have just put that in as a division problem. Yes, good, CJ. Okay. Now, last type of problem I want to show you that you might see on a test, and this is pretty silly the way they write these, but it still might show up on a test. they're going to give you approximates. So they might say that log base 5 of 11 is approximately 1.490. And log base 5 of 30 is approximately 2.113. Now you can check those on your calculator. You can hit math, go down to log base and fill those in and check, but they're giving you that, so they're assuming you don't know how to work your calculator. You're more of a doofus than I am. So they're giving you that, and then they say use that to find log base 5 of 11 over 30. All right, I'm going to show you what's intended, what they expect you to do, but then I'm going to show you the easy way to do it.
What does that other equation?
Log base 5 of 30 is approximately 2.113.
Oh, okay.
So what's intended, what goes with this lesson, is this is the quotient property, right? That's what goes with this lesson. This is not the easiest way to do it, but what's intended, this is the quotient property. So I can rewrite this as a subtraction problem. So I could rewrite this as log base 5 of 11 minus log base 5 of 30. Now they've given me those values, right? So 1.490 would be this value, right? So I would say
Oh, I see what you're doing.
1.490 minus this value is 2.113. Okay? And then I'd subtract that and get negative what?
Negative 0.623.
All right. Okay. So that's how this goes with this lesson. And I don't have a problem with you doing that at all. Okay. Not very difficult. I think if I were you and I was doing this on the ACT some glorious Saturday morning and I was given this, I would just hit math, log base, fill in your base of 5 and your fraction of 11/30ths. You'll get the same answer. Okay. So if it were me working on a test, I would not go through those steps. But me as the math teacher, they want us to see if you can do that, so we did. Okay? You following that there?
Yes, ma'am.
All right. What we've got on the horizon still tomorrow, we're going to do another assignment, trying to get some good assignments out of this. So this is new stuff, so we're going to look at another assignment tomorrow. It'll be more just the BEN and log base B of NE. That stuff would be more of that. We'll look at that tomorrow. And then next week we just got a couple of things left to look at. So I'm planning on doing a log test on Friday next week. Not tomorrow, Friday next week. Okay? That's what I'm planning on. Not set in stone, but looking good for that. Okay, doke? Not hard stuff today, just rewriting stuff. So nothing to be worried about with it.